This video is going to cover the practice questions at the back of booklet 4, literal equations or rearranging formulas. Number 1 is asking you to solve, rearrange the equation for V1. So right now the question says V total equals V1 plus V2 plus V3. All the terms to the right are added together. So to move the other terms away, the V2 and the V3, bring them across the equal sign, but change the sign. So V total minus V2 minus V3, that would equal V1. Pretty simple rearrangement, and that's it. For question 2, should look familiar. The circumference of a circle is equal to 2 pi r. When you want to solve for the radius, you've got to rearrange it from the original format. So right now we've got the radius multiplied by 2 and multiplied by pi. So the opposite would be to divide both sides by 2 and pi, and that would cancel the 2 and the pi away from the radius on the right, leaving you with just the radius. The radius is going to equal the circumference divided by the product of 2 and pi. If you're doing the math with real numbers, you take the circumference and divide it by, use brackets, 2 times pi, and then divide into the circumference will give you the radius. You'll see a question like that on your assignment, in fact. Number 3, put a formula that relates mass, velocity, and an R. It's a physics question, probably to a force. Usually that's what F stands for in physics. So to solve for M, you've got M trapped inside of a fractional equation. You want to get the V squared gone and the R gone. So first step would quite literally be to get rid of the bottom of the denominator. Let's multiply both sides by R to make it disappear. If I do this in steps, if you skip steps, you're going to get caught sometimes being overwhelmed. Times that side by R, times this side by R. Rewrite what you have left. R times F is going to equal mv squared. And you want to get the m by itself, and the m right now is divided by v squared. So the opposite would be I shouldn't say is right, it's multiplied right now. You need to divide it by both sides. So I rewrite it, it's divided by the right by v squared. The v squared will cancel as long as you do the same thing to the left. The equation hasn't changed. So m is going to equal r times f divided by v squared. Back up to the original question. You were also asked to solve for v. So if you take your original question, f is equal to mv squared over r times both sides by r. That gives you r times f equals mv squared. You want to solve for v, let's get rid of the m. If you divide this side by m, that side by m, you're left with v squared equals r times f over m. Now last but not least, we're not done because we want to know what v is, not v squared. The opposite of a square is a square root. So that will cancel, leaving you with just a v, as long as you do the same thing the other side. So r times f over m. Now notice, very Christie typical, careful observation, the square root sign must come down to cover and include the bottom of the fraction and not just the top. It's the whole thing. It's r times f divided by m, get an answer, and then take the square root to solve for your v. So if you're not careful the way you write it, you will find out that it'll cost you. 4. You've got V equals VO plus IR. You're trying to solve for R and I. Either one of those terms is not attached to the VO. Bring the VO over to the other side by changing it to its opposite, which is a subtraction. Now you're down to this stage. Depending on what you want to get rid of, if you want to solve for I, you would get rid of the R. So V minus VO over R. If you divide it both sides by R, that would give you the formula for I. If at that original stage you wanted to solve for the R, you would have taken your V minus your VO, and you would have divided both sides by I. And that would have allowed you to solve for R. So the R is going to equal V minus VO divided by I. Make sure your fraction includes the entire top, V minus VO, to be correct. Same thing over here. It's got to cover both terms. Number 5. M equals O times A over F subscript V. Not F times V, but F little v. To solve for A or to solve for O, you need to get rid of the fraction. You need to multiply both sides by the denominator. Multiply this by F little v. Multiply this by F little v. The question becomes much simpler. OA. Now to solve for O, you get rid of the A. To solve for A, you get rid of the O. So depending on what you want to solve for here, let's solve for the A first. You would get rid of the O. So the A is going to equal F little v times M divided by O. And over here, if you wanted to solve for the O, you would have gotten rid of the A. So you would have gotten rid of the A, leaving you with O. And you're done. That question is fairly straightforward, only has one term, right and left. Now for number 6, you must be careful which V you're trying to solve for. It says in the question you want the plane V. Well, this plane V right now is trapped in a fraction, and the denominator is t. So we're going to multiply both sides by t. This whole unit is only one term. So you multiply by 1t and multiply by 1t on both sides. The t cancels. You're left with AT equals V minus VO. Now to solve for the V, you move the VO, which is minus, to the other side and change the sign. So it's going to become plus VO. Now if the question had have asked you instead to solve for VO, it would actually be a little bit harder, and I'm going to do it. If you had been asked to solve for VO, and you only moved over the V, you would have had AT minus V equals a minus VO, which you cannot leave. You've got to divide every single term by a -1 to get the negative to cancel. What that means is every single term is going to change its sign. So you're going to be left with a positive VO, a minus AT, plus a V. So just be careful on your assignment when you come to a question that has a negative sign in front of your variable, you're going to have to figure out a way to clear that negative away, because you can't have a negative in front of your letter and you can't have a negative in the bottom of the fraction. Both of those scenarios are illegal. Solving number 7 for big E. You want to solve for E. E is trapped in a fraction. Let's multiply both sides by k to clear the fraction. Multiply that side by k, that side by k. You're going to get ER squared. You want to solve for E, you're just going to have to divide by R squared to both sides. Doesn't matter that the R is squared. There's no square rooting because you're asked to solve for E. And E is not squared. So you're done with the first part. Now, if originally you were asked to solve for R, as you are over here, you would do exactly the same thing. Multiply both sides by k, and this line would look exactly the same, and you would get k times q equals ER squared. Now, we have to divide this time by the E to get the R by itself. So you divide by E, and you divide by E, and your next line would read R squared equals k times q divided by E. And as you know by now, to get rid of a square, the opposite is the square root. So if you take the square root of one term that's squared, it'll cancel. But you must take the square root of both sides to maintain the balance. So k times q over E. Note the root sign goes all the way to the bottom of the fraction. If you had numbers, you would fill in k times q, divide that by E, and then at the very last step, you would take the square root of that quotient and get the value for R. For 8, you're asked to solve for A and you're asked to solve for X. Both of those numbers are inside the bracket, so your first order of business is going to be to clear the bracket. You're going to get R equals AC plus CX. You want to solve for A, you've got to get the A term by itself, so we have to move the CX to the left. So we're going to get R minus CX is going to equal AC. And when you want to solve for A, you've got to get rid of the C. So it's A times C. The opposite would be to divide by C. R minus CX over A. So you're left with R minus CX over A. And that's the value for C. If you were asked to solve for X, then this first step, after the bracket was cleared, R equals AC plus CX is the same, but now we're going to move the AC to the left. So R minus AC is going to equal CX. And you want to solve for X, so you're going to divide by C, both sides. You have one C term on the left, C on top, C on bottom is going to cancel. On the left, you cannot cancel the C's because there's no C term with the R to cancel. So you can't do it for half. You've got to keep it as R minus AC over C. And there's two answers for that equation rearranged. For number 9, you're asked to solve for R and E. So separately, you need to clear the fraction because the R is in the denominator. So if you, that should be a P. If you need to rearrange the formula for any component on the bottom, then you're going to have to clear the fraction first. So if I do this, times both sides by R, then the R is going to go away from the right, but it's now going to be on the left, and it's no longer going to be in a fraction. So now I'm asked to solve. Once you get the r gone, you can use this, not gone, but moved. You can use this form with no fractions to solve for either e or r, based on the two questions you are asked. So to solve for the r, what I would do is I would get rid of the p. I get rid of the p because the p is multiplied by r. I'm going to divide both sides by p. And you're done. R equals e squared over p. And that's the first one completed. To solve for e, you need to do a little extra step. R times p equals e squared. To solve for e, you need to do the opposite of a square and take a square root. And that's no trouble, because that cancels with that. As long as you do the same thing over here, you're good to go. So the value for e is going to equal resistance times the power will give you your voltage, E. And there's the formula for E. And the last one, solving for t. T is trapped inside of a fraction, and it's also a square root. We must be clever. It's going to require a square root at the end. To get rid of the 2, we need to multiply both sides by 2. So 2 times s is going to equal at squared over 2 times 2. 2's are gone. You're left with 2 times s equals at squared. You want to solve for t, not at squared. Let's get rid of the a. Divide left and right by an a, so the a's can cancel. Now you have t squared. So then you have to get rid of the square by doing the opposite, which is a square root. Take the square root of both sides. Your final answer will be t is going to equal the square root of 2 times s divided by a, or 2s divided by a, all taking the square root of that to get the value for t. And there's the 10 practice questions with some extra halves parts for you to practice the concept of rearranging formulas. Hope this helped, and I hope your assignment's a little easier. Good luck.